Help create an artistic expression. But unfortunately, well, up until now, the tools that you've had at your disposal are basically geometric building blocks of sound. And you use these to try and paint uniform sound in 3 dimensions in a room. So it's a bit like painting with audio pixels. And in the area where the pixels touch, you may have destructive interference. There may be areas where there are gaps. So certainly, for some seats in the house, the experience is not exactly what the artist intended, and what we end up with is, in essence, a compromise. And frankly, I think our industry has settled for the compromise because generally, it's better than it was a long time ago. But what if we didn't have to settle? What if we had a system that made it so that every seat in the house could truly experience exactly what the artist intended? And that brings us to Anya, a system with adaptive performance capability. It has the ability to adapt its 3-dimensional performance characteristics to perfectly match the requirements of a very specific audience in a very specific venue. And because of this capability, it's actually the ultimate expression of EAW's founding principle. So at this point, I'd like to introduce you to Anya. I certainly hope you enjoy the show. I'd like to invite our Director of Engineering, Nathan Butler, to the stage. He will give you much more detail about the core technologies behind Anya. Nathan.
Thanks to all of you for coming out this evening. We certainly appreciate it. Thank you. As Jeff alluded to with the mosaic, the ideal solution, the ideal system that we envisioned in Anya was one that would have the ability to completely adapt its output lobe to exactly match the requirements of the space. And I'm not just talking in terms of the actual shape of the space. I'm talking in terms of the response of that system, not only the level, but also the shape. Really trying to maximize everything to give every listener the best experience they possibly can. And this isn't really a new thought for EAW. We started talking about this years ago, actually back in the 90s, and in fact made a first pass attempt at it with the introduction of the KF900 system. Some of you may be familiar with it. One of the biggest flaws, or there was actually 3 flaws with the KF900 system. One, it was externally processed and externally powered, which meant the setup was extremely time-consuming and complicated. Second, the high-frequency spacing was such that we didn't really have the ability to radically alter the vertical coverage, meaning that we had several dedicated modules within the KF900 line that directly addressed all possible scenarios that you might experience in a venue or a given number of venues. And last, and perhaps most importantly, there was no software package, user-accessible software package that allowed a user to easily and quickly configure the system for night-to-night or even within a performance, any changes that might be necessary. The real first system, which was actually just a few years later in the early 2000s, was the DSA series. For the first time, we had integrated amplification and integrated DSP. We also had transducer spacing that allowed us to completely vary the coverage, pretty much to plus and minus 90 degrees in the vertical plane, to give us the ability to match the coverage of that system to the space. And most importantly, we had a simple-to-use software package that with just a few basic inputs about the venue, a user could very quickly and easily configure that system. But it still lacked the ability to do any adjustments truly 3-dimensionally. The horizontal pattern was fixed. Another limitation at the time, essentially tied to the limitations in technology in terms of amplification and processing, and frankly, the PCs at the time, the software capabilities, we weren't able to bring DSA to the real scale that we wanted to cover some of the larger performances that we really wanted to cover with a system like Anya. One of the things that we all know is that there we go, that the throw differential from near to far, front to back, is much greater than what we have left to right. This is one of the reasons for the predominance of line arrays in our industry today. Line array system does a very good job at tailoring the sounds to be fairly even from the front of the venue to the rear, but it really does nothing in the horizontal plane. And in fact, we've given up something that we used to all have with the horizontal arrays of years ago. So with this in mind, we knew that the solution that we would be looking at in a system like Anya would rely quite heavily on the basic two-dimensional concept of beam steering from products like DSA and similar to cover the front to rear coverage requirements. But we would rely more heavily on the traditional physical aspects of the horizontal array system to cover the needs in the horizontal plane. But we didn't stop there. What we actually envisioned was several very long vertical ribbons of sound arrayed in a horizontal arc, each one of those ribbons with discrete control, and then actually within each one of those ribbons, additional discrete control of very small segments. With that level of control and that number of vertical columns of energy, we would have the ability to almost repaint the mosaic, to use Jeff's analogy. Basically turn the sound system into a similar mosaic of the picture that we were trying to paint on the floor. The way we would do that is to actually use the venue and project the venue definition back to the location of the array to really give us a definition of what that mosaic needed to look like. But of course, the picture I have painted here is a two-dimensional representation. It's a two-dimensional solution to a very classic two-dimensional problem. To fully employ the capabilities of what we wanted to achieve with Anya, we would want to take a look at the three-dimensional space, same concept, project the venue back to the array to give us a three-dimensional idea of what the array needed to do and what the load needed to look like. And we have that within Anya, especially as you start building arrays larger and larger, more boxes. We end up with discrete vertical segments of energy, low, mid, and high, lows and mids replicated left to right to give us the horizontal control that we needed. Of course, we get additional horizontal control as we make multiple columns of Anya systems. Before I go into a detailed explanation of how we developed the acoustical package and the physical package, I thought I'd give you a quick overview and a kind of a sneak peek snapshot to the inner workings or the inner design of an Anya module to help you better understand what's going on. I'm going to start with the low frequency device because we knew early on that we wanted the system to be based around a 15-inch woofer. There's a lot of reasons for it. Fundamentally, we knew that a 15-inch woofer would give us the output that we needed, the punch of this type of system that's demanded of this type of system. But additionally, a 15-inch woofer kind of set the foundation for a physical package that was easy to handle and easy to transport. The basic building block was not going to be overwieldy. The 15-inch woofer that we ultimately developed borrowed many technologies from many components that we had developed in the past. The result is a lightweight neodymium 15-inch woofer with a 4-inch coil that has extremely high excursion and extremely high output. I should also mention that the physical dimension of the 15-inch woofer was acceptable for the radical vertical adjustment that we wanted to achieve with that device. We had full capability to do that with an array of these devices over the entire operating bandwidth of that subsystem. Of course, we couldn't pay attention to just the vertical, right? Because we knew that we also wanted to modify and control the coverage horizontally. So, as we've done with many EAW systems, KF730, KF740, we use unique techniques, in this case, strategic placement and size and positioning of the apertures and the ports tied to the low frequency devices to ensure that the natural horizontal pattern control that we achieve from that low frequency section naturally matches the 70-degree pattern that we had already defined for the mid and high frequency section. So we have an extreme extension of beam width into the lowest operating range of that 15 device that perfectly complements what we're receiving from the mid and the highs. But putting those low frequency apertures right in the middle of our large mid and high frequency horn didn't really mean well, or didn't mean good things for the mid and high frequency sections themselves. So we went on to fill each one of those low frequency apertures with a formed grill that ensured a smooth and continuous horn surface for that mid and high frequency wavefront. With the low frequency section defined, we were able to move on to the mid and the high frequency section, which were really designed in parallel. They were designed together because the two systems interact with one another so closely, and getting that really crisp mid and high frequency transient response is so important in a system like this. But I'll start with the high frequency section and then give you an explanation of the mid frequency section. From what we learned with DSA, we knew that very tight source spacing gave us the ability to radically alter that vertical coverage, again, as much as plus or minus 90 degrees. And we actually set the bar a little bit higher for ourselves when we were designing Anya, because it is such a radically different and high-level system. We actually wanted to reduce the spacing from what we had actually achieved in DSA, which was much closer to 3 centimeters. For Anya, we set the target at 2.5 centimeters. And of course, this meant that we couldn't really rely on the typical compression driver, the typical compression driver size that we would use in a system of this scale. We had to go to something much, much smaller. So, very similar to the 15-inch woofer, we started really from the ground up on a new design that resulted in a 35 millimeter voice coil device with every aspect of the design optimized and refined to precisely match our needs. Most notably, a specifically designed neodymium magnet structure that's asymmetric, giving us the ability to get the extremely tight vertical spacing that we require. Of course, we wanted to fit as many of these within Anya as possible. And although the system is relatively tall, each module from the 15-inch woofer, it still meant that we had to do some additional tricks to squeeze these in there. What we ultimately wound up developing in tandem, we knew early on that we'd have to create a high-frequency manifold to bring several columns, ultimately we settled on 2, of these devices into a single column of 14 apertures. So it's a very unique manifold, patent pending, that brings the 14 HF devices into a single column of apertures, 1-inch spacing between them, that actually continues for the entire height of the array once you start building multiple Anyas together. With the high frequency section done, we were able to move on to the only thing that was left, the mid frequency. And building on the heritage of many EAW designs, wanting to retain the horizontal symmetry, we knew that we would have 2 sections of mid-frequency devices flanking the high frequency, the central high frequency section. We also knew that we wanted those mid-frequency devices or apertures as close to the high frequency device as possible, allowing us to get that time coherency that's so critical. This requirement allowed us to employ 2 proven and patented EAW technologies. The first is the radial phase plug. It was introduced many years ago in the KF750 system. The radial phase plug improves the time coherency of the mid-frequency wavefront itself, while also improving the loading, the impedance loading of the mid-frequency cone to that high-frequency horn. The second technology, the CSA technology that we introduced in the AX series in mid-2000s, thereabouts, that randomizes the size, shape, and location of the mid-frequency apertures to have minimal impact on the high-frequency wavefront. Since the 2 subsections are sharing the same horn, getting them to combine, we need to pay quite a bit of attention to how that's done. Of course, giving so much focus to the mid-frequency transition didn't mean that we could just ignore the mid-frequency component. Like the high-frequency component and the low-frequency component, we almost started with a ground-up design. Every aspect of the device, from the magnet to the coil to the cone, was optimized to give us the performance that we needed. We chose a 5-inch device because, like the high-frequency section, we wanted to get these devices as close together as possible, giving us that ability to operate these devices and manipulate these devices over their entire operating range. Lastly, the rear can, the enclosure that's on the back of this device, gives us optimal air volume for that mid-frequency transducer, and also provides quite a bit of additional thermal mass and heat sinking, giving us the ability to remove more heat and improve power handling for improved output capability. With the acoustic package completed, there's many aspects that led to the beautiful shape that we have in Anya. The large, continuous, high-frequency, mid-frequency, and even low-frequency horn really became the basis for the overall aesthetic design of the system. And also, with the adaptive performance technology in place and the straight-line acoustic solution that we developed, we were able to create a rigging system that's complex and robust, yet extremely fast and easy to operate. The result is the Anya system that you have here, a photo here that we took in one of our labs, Frank's favorite, wherever he is out there, speaking to him earlier. But we really feel it's one of the most beautiful products that has ever been in EAW's catalog, if not one of the most beautiful products that's available today. Now, of course, none of this would be possible. I just spent a lot of time talking about the acoustic and physical package, but let's be honest, everything that we're talking about wouldn't be possible without a fairly sophisticated electronics package. There's 22 transducers in every Anya module, for those who weren't keeping count. 2 low frequency, 6 mid frequency, and 14 high frequency devices. So we worked closely with 2 partners, both PowerSoft and Audinate, to develop an amplifier module that's networkable, that gives us the ability to control and monitor all of the aspects of an entire Anya system. While in front of those is a DSP of our own design, implementing many of the algorithms and improvements on those algorithms that started 10, 15 years ago with the KF900 and DSA. And of course, I told you before, one of the biggest downsides to some of our earlier attempts was the lack of an easy-to-use software interface. Resolution, which we actually first deployed with KF740 back in 2009, was pretty much torn apart and rebuilt because we added 2 major features to the software to allow us to use it with Anya. The first, of course, was the network control. We needed to take what we were modeling in the software and actually create the parameters and then send those parameters over the Dante network to the Anya system. The second was to fully exploit the 3D capabilities of Anya. We needed to give the user the ability to create a 3-dimensional space. Prior to Anya, resolution had only existed in a 2-dimensional realm. So it was a huge undertaking to take resolution, completely tear it apart, change it from 2D to 3D, and give us the software that we have now. But we still feel, like the rest of the Anya system, every aspect, every design parameter was carefully thought out before it was fully implemented. Because for many, resolution is actually the only, or will be the only experience that they have of Anya. So like the product, we wanted the control interface to be just as robust and just as refined as the product itself. And that's it from me. I just want to close by saying that in all my years at EAW, this is obviously, I think it goes without saying, one of the most complex systems I've ever worked on. It's almost also one of the most fulfilling. And there was many talented individuals who were involved in its development, both within and outside of EAW. And they all deserve a big thank you. So without further ado, I will turn it over to Bernie Broderick, our technical training manager, who will review some of the real-world use cases with you.
Thank you very much, Nathan. I'm truly entertained when I stand off to the side of the stage and listen to people like Nathan and Jeff Rocha talk. It's always great. Okay, let's try something else. There we go. The virtual world, resolution. Unfortunately, I can't take all of you and put you in that virtual world. We live in the real world where equipment needs to be transported, rigging needs to be installed, cables have to be pulled, testing has to be done. There are so many things to consider when you install a live sound system. We all know this. As much as I would like to easily transport you into the virtual world, I simply cannot. I have to work in the real world. As a matter of fact, I've been working in the real world all day. When I joined the company about 8 years ago, very shortly after I joined the company, the concept of Anya was born. So we have probably the world's best kept secret in audio for being able to completely develop this system under the radar of everybody. And it also gave us a lot of years to consider how the system would be transported, how it would be rigged, what kind of features would be useful to the end user. It's all about the end user. We have crew guys here that we have to deal with, and at the end of the day, we need to hang a sound system that a front of house sound engineer is going to stand at his console and say, it sounds great. He doesn't really care about all the directivity changes and all the amplifiers and everything else. It's a very, very simple equation for him. Push up the faders, make it sound good. But for us, the technicians who move the system around, it's more important to us. So we need those features. We want to speed up our day, we want to have fun, we want to go to catering, so many things. Over those almost 8 years now of working with Anya, we've built in as many features as we thought were usable to the technicians and the people that operate the system. As a matter of fact, you may be surprised to know that there's some hardware in Anya that we haven't even taken advantage of yet. We overbuilt everything, so we would have a very, very long life cycle on the system. It's no good 5 years from now to wish you had done something with a system mechanically. It can't be undone once it's built. So we said, let's be forward thinking. Let's put things on there. We don't really know what we're going to use them for yet, but we know they're going to be useful at some point, so that's what we did. But let's talk about some of the features that already exist in Anya and look towards the future for the things that we hope to add. The first thing we need to do is we need to bring a system in and we need to assemble it. Now, because Anya orients itself both vertically and horizontally, we had a small mechanical problem that we needed to deal with. We needed a square dolly to transport the enclosures for stability, but we also had a trapezoidal-shaped enclosure, and if we were going to be able to link these together in horizontal columns, we needed the sides of the enclosures to touch so we could lock them together. The engineering department at EAW, the mechanical engineers, did a brilliant job in coming up with this concept, and it's so interesting that we even highlight it here in the venue for you to look at. First of all, we have a steel frame, very heavy-duty wheels on a steel frame, and the plate that you see on top of this steel frame works on a ball bearing system and is allowed to rotate on top of the steel frame. The reason why we do this is that when you rotate the top plate, it exposes the flat side of the enclosure so that you can roll up another pallet of loudspeakers and interlock them all together. Interleaf the pallets in a semicircle, pre-lock them all together, and lift them all up into the air at the same time. Once you're done, you bring them down in the same manner. They self-guide them into the runners that are on the plates, rotate the pallet back forward, lock it down, and send it onto the truck. It works quite well. I've been using it quite a bit. That's not the only interesting thing about the pallets. This is very interesting as well. Each pallet is designed to hold the weight of 18 enclosures. Why would we be rolling around 18 enclosures, right? No, the reason for that is that because we need to drop each of the columns down, we kind of looked at it and said, well, what could happen if the gentleman running the motor control dropped the whole weight of 18 boxes, which is our maximum in a single column at 10 to 1. What would happen if you dropped that all on top of one pallet? You can obviously assume that it would crush it. So instead of taking that chance and having some upset users out in the field because now they have to hand bomb a bunch of enclosures around, we decided to make the pallet strong enough to accept the weight of all 18 enclosures in the column. And that way we were sure that you were never going to run into any problems in that regard. The rigging on Anya could not be easier. Hopefully most of you have been by the booth and have had a chance to experience, but there's really very, very few steps involved in rigging Anya. The days of handing out the printed sheets of angles are gone. You don't have to show up in the morning with the riggers anymore and shoot the room and do the model all in advance. You really don't. Anybody can quickly be trained on rigging Anya. There's very, very few steps. You literally just drop the slugs out of the bottom of the cabinet, put the column on top of another column, slide the pin through, take the array back out again. It couldn't be easier. The bumper itself rides on top of the stack. Anya has no external rigging whatsoever, including the bumpers. They ride on the stack, and even the bags that we make for Anya have pockets in the top to make sure it covers the bumper at the same time. Again, we were looking forward thinking, what could our customers run into? So we decided to give you as many different rigging options on the bumper as we possibly could. Of course, you can hang the system with single motors in the center of the bumper. The array will hang completely straight. You may elect to use 2 motors, left and right. This is great for no spin. And in some rare instances, you may even need 3 or even 4 motor points. As I said, we've given you as many different options as we can. Now, also unique is the way the bumpers interlock together. We have a set of bullets on one side, which work on a cam lever. On the other side, you can see that there is a keyhole. So when you put the bumpers together in the stacks, first of all, you're greeted with a lot of play in the assembly. If you have uneven floors, we never wanted you to run into issues putting the bumpers together. So this cam lever, when released, gives you excessive amounts of play to be able to join the bumpers together. When you rotate the cam handle, it draws all of the slack out of the bumpers and pulls them together tight for you to be able to put it up in the air. The system has data logging built into it. While the system is in operation, actually right now as we're speaking through this system, Anya is self-monitoring. It's monitoring its impedances, it's monitoring its temperatures, it's monitoring all the activity that's going on inside the amp module. And it's logging this information. Every couple of minutes it logs information. If anything were to happen during this performance, if we were to lose an amplifier module, if a component was to fail, if anything happens inside the electronics package, it will be logged. On the back of each Anya, there is a small button for test. This is a battery-operated feature. If there's an error in the system, this light, when you depress that button, should turn green if everything is good, but it will turn red. And this indicates to you that something happened with that particular enclosure during its last performance and needs to be inspected. The feature is battery operated, so as a rental company at the end of this show, we could drop down these arrays, press all the test buttons. If everything turns green, that means that everything is nominal and nothing happened at the last event. The system is fine. It can be turned around quickly and sent off to its next performance. Now also, on every side of the amplifier module, we have infrared sensors. For those of you that have ever worked with network systems before, you may have run into having to assign each individual enclosure to a model. So everything needs to be assigned. Usually you see a bunch of LEDs coming on and you need to drag over things and get everything assigned in the model. We saw this as a time-wasting effort, and we built into the infrared sensors to help speed up that process. When you physically assemble an Anya array, both vertically and horizontally, and power the system up, all of these infrared sensors will talk to each other. We call it the buddy list. So all the boxes talk to each other. They know who's to their right, they know who's to their left, they know who's above, and they know who's below. When this happens, it will duplex that information back to the resolution software, so what you'll be greeted with when you bring up the system is complete arrays. You don't have to do any assignment of cabinets. All you have to do is tell the software which array is left and which array is right. That's all you're going to have to do with regards to assignments in the system. This is a very interesting thing about Anya, and I made a little bit of a mention of it earlier. You don't have to do your model before you hang the system. There's literally 3 practical things that you need to consider. Horizontal coverage, you need to know the spacing between the arrays, and you need to know what the trim height is. These are 3 things that intuitively most sound technicians can figure out quite quickly. How much coverage in the horizontal am I going to need? How high am I going to fly the system? And how wide are the arrays apart? Once you know those 3 things, you can go ahead, mechanically fly the system out, get it out of the way. Let the lighting designers come in and do their thing, let the stage guys come in, set up their equipment. While they're doing that, you can be sitting at front of house now doing your model. Because Anya is not dependent on any mechanical forethought in deploying itself in the vertical domain. All of this stuff can be done after. We have acoustical GPS, for lack of a better term, but we do have a better term. We call it trilateration. This is an excellent feature using the Smart 7 software. We use the API for Smart 7 to interface into our resolution software. What the trilateration routine allows you to do is fly out your system and be able to locate a microphone anywhere in space in front of the system through the use of 3 sound bursts from Anya. This could be very useful for mapping a room, as an example, and it can also be used to confirm the coverage of a room. In this particular room, we can take a microphone to the top seat, we can run the trilateration routine from Anya, and it will isolate and find that microphone out in the audience and immediately display that microphone position in the software. So now we can see and confirm whether or not the model that we developed and the coverage that was defined actually matches the real world. And we can do it down front as well. So it's a very valuable little tool in there to work with. Do this all around a venue and you can literally map a venue using this feature. Sooner or later though, things happen and service needs to be performed. As we know, we have to do routine maintenance on our loudspeakers, and we have to check that they are running properly and doing the things that they're supposed to be doing. Anya has built-in microphones in every enclosure. So in the face of each Anya box is a condenser microphone. At the factory, there is a final QC where every single device inside an Anya enclosure must meet a tolerance plus or minus in frequency response. This is absolutely necessary for directivity control and keeping the sound quality very high. Once those devices pass that plus or minus test, those reference curves are stored inside of the memory. Now it travels with the enclosure. But from time to time, sound companies need to test their equipment. They need to know whether the integrity of all the components is good. And this is what we do with Anya. You bring it into your shop, hook the enclosure up to the resolution software, and run a self-test. Each individual device in sequence will emit a sound burst. That sound burst is then heard from the integral mic in the enclosure and compared against the plus or minus reference curve that's stored in the Anya enclosure's memory. If the device falls within that plus or minus, it will indicate the device passed. If it doesn't, of course, it will indicate that the device failed. This doesn't mean that the device is not working. It may simply mean that the device is tired. It's been worked hard. It does not comply anymore with frequency response against the factory stored curve. So it's time to change that device. Once you've changed the device, you can now test it against the original curve from the factory. And that will give you a plus or minus pass on the new device. Passes, you can now overwrite the old frequency response curve and store a new curve for that particular device inside of Anya's memory. So this is the way to keep your equipment up to date and keep it up to snuff. All right, so that's, I'm sure there's more features. Every day I find more. We have many things going on with Anya. But I think it's time that we hear the system. Do you agree? All right, we've been talking a lot about it for the last few days at the trade show, and I know a lot of you are excited to hear what we can do and the tricks that we can perform with the system. I just wanted to say one thing about my experience with Anya, and arguably I've probably done the most live performances with the system of anyone. In the days of line arrays, now that I'm using Anya, I found that there was a lot of times with a traditional line array where I would have liked to have made a change, but because of the trouble involved, I basically just wrote it up and said, no, it'll be good enough. I constantly find myself with Anya making the changes that I always wanted to make. This room was no different today. We came into this room, we set up the system, we started testing, and we were hearing an annoying little slapback in the back of the room. And all we did was adjust the coverage down a bit. You might even be hearing it up there. We have a little bit of a roll-off at the top because we were getting a little slapback here on stage. For a traditional system, this would have required tilting motors, maybe re-angling the entire PA. For us, it was nothing but a couple of keystrokes. And I find myself time and time again making these subtle changes to improve the overall listening experience and for you, and in this instance for us here on stage. It made a huge difference for us today. So let's listen to some music. What we're going to do is we're going to first give you the opportunity to hear the system in its full range capacity. So let's just get a sense of what Anya sounds like with music through it. Then we're going to do some really cool things with the directivity. One of the huge interesting things about Anya is that when we change the directivity of the system, we don't have to stop the music. We don't have to turn the system off and then reload and then turn it back on again. We're able to change the directivity while the system is running, which I think you're going to find very entertaining. Obviously, this is probably not something radical like you would do in a live performance, but when you think about it, if you're doing a large festival that maybe has a lot of noise problems in an area, consider that in the morning, maybe the crowds are not very big. You can change the directivity of the system to match the audience that's there. And as the day goes on and the crowds get bigger and the headliners approach, you simply start opening up the coverage of the system to match the audience size. This is going to score you some huge brownie points with the neighborhood for sure. But for right now, let's just start with an overall listening experience. This is Anya with our formidable SB2001 dual 21-inch subwoofers and our KF200NT self-powered loudspeakers for front fills. Adam's going to play a track for you now. Time to have a little bit of fun. So what we're going to do is we're going to stop right there for a second and we're going to start another track, and we're going to shift the directivity of the system
just to the front of these seats here, and you're going to hear it happen in real time. You guys back there are in for a bit of a treat. So we'll fire up the next track, and then we're going to make the shift in real time.
I can feel no sense of measure, no illusions as we take refuge in young man's pleasure, breaking down the dreams we make real.
One down, one to go. Another town, one more show. Downtown, you're getting away, but you never came
Oni
back.
wierzą cały czas, zmieniają.
No phone, take your place, you know what I mean. We have the same dream.
Okay, so now we're all down here. Welcome to my side of the world. While you're all standing here, we're going to prepare for the next shift, so don't go away. Just stay right where you are, and we're going to play another track. While you're standing here listening to this, we're going to shift the entire coverage to the bleacher section, so you guys can hear back there too, okay? All right, so we'll play another track, and when you see me do the thumbs up, you'll hear the sound move.
There will be no consolation prize. This time the bone is broken clean. No baptism, no reprise, and no sweet taste of victory. All the stars have fallen from the sky, and every place between satellites have closed their eyes. And
Here I am inside a hotel, choking on a million words I said. Cigarettes have burned a hole in dreams I've drunken penniless. Here I am inside my father's own hard jacket, rolling whiskey dry. Whisper to me sweet, and tell me I will never die.
Hey everybody, how you doing back there? All right, so now we're going to go back to our original coverage. We're going to cover the entire room again, and we're going to play the original track with some subs, and you will hear the entire system come back down on the floor again. So let's fire up some music, and then I'll give them the thumbs up one more time, and we'll bring it back down to the floor. no demo is truly complete without a bit of throttle, right? All right. I'm going to play you one more track. I know that everybody's always interested in the system's capabilities, what it can do under a little bit of duress. And then we're going to give you 5 or 10 minutes to cool your ears off, and then we're going to have a wonderful duo that's going to come up here and do some live music performance for you. As I said in the very beginning of my presentation, this is all fantastic, and I'm super glad that you're having a wonderful time out there, but at the end of the day, we've got a guy standing back there at a mixing console, and we have performers coming up on the stage, and all these people are concerned about is how they sound through Anya. So we'll give it a little bit of juice. We hope you enjoy it, and then we'll come back and we'll do some live music for you.
So there you have it. That's the end of our formal presentation. Once again, we are so grateful for you spending the time with us and coming to experience Anya. We invite you to mull around, have some drinks, have some great conversation, and please reach out to any of us. If you see an EAW representative, any of the people that were up here, please don't hesitate to approach us to ask your questions. We're going to take about a 5-minute break or so, maybe 10 minutes, and then we're going to have some live entertainment. So once again, on behalf of EAW, thank you.